In this video, I'm going to go over series and parallel resistors, how to find their equivalent resistances, and then do some examples. So I'll start with series resistors. So for series, it's just when you have resistors connected like so, and then R1, R2, R3. And for this, the equivalent resistance is simply the sum of all the resistors. Can be as many as you want. So that's the general formula. So let's say we had 3 resistors, 3 ohms, 4 ohm, 5 ohm. The equivalent resistance for this is literally just 3 plus 4 plus 5, and that's just equal to 12 ohms. So that's all there is for series. So now for parallel, that's when you have resistors connected as if they're parallel lines. So something like this. So R1, R2, R3. Now, the formula for resistors in parallel is a little different, and it is 1 over the equivalent resistance is equal to 1 over R1 plus R2 plus 1 over Rn. Now that's the general formula. It's a little bit harder to use because this Req over here is in the denominator, but most of the time you're really only going to run into a couple scenarios. So let's say we had something like this with 5 ohm and let's say a 10 ohm resistor. Now we can use this formula to get the answer, but we can also just remember an easier to use formula, which is derived from that formula. And that's for if you have 2 resistors, then the equivalent resistance is just R1, R2 over R1 plus R2. So in this case, the equivalent resistance is just 5 times 10 over 5 plus 10, which equals 50 over 15, which is equal to 3.33 ohms. Now, that's the main scenario you're going to come across. The other one, not as common, but you might see it, is just when you have 3 resistors connected in parallel. So let's say 5 ohm, 10 ohm, 15 ohm. Now, again, we could use this formula from above, or we can remember the more convenient R1, R2, R3 over, it's basically like the previous one. You multiply all the resistances and then you sum the combinations. So in this case, all the combinations are R1, R2 plus R1, R3 plus R2, R3. So now in this scenario, REQ it's going to be 5 times 10 times 15 all over 5 times 10 plus 5 times 15 plus 10 times 15. Now that is going to be equal to 750 over 275, which is equal to 2.72 ohms. All right. So now what if you have a scenario where you have resistors in both series and parallel? Now that's what we're going to look at with this example. So here we just want to find the equivalent resistance of this circuit. So you have to do this step by step. So basically you're just going to keep reducing it until you only have one resistor left. Just keep combining resistors until you can't anymore. So the first step, by the way, this triple equal sign just means equivalent. So the first thing you're going to do is you're going to see these resistors. Those are all in series. So you can just rewrite the same circuit. But now you can just combine all of those three resistors into 4 plus 5 plus 3 is just going to give you 12. So now that's 12 ohms. And then you keep the rest the same. So you got a 4 ohm, a 3 ohm, 6 ohm, 4 ohm, 3 ohm. And now you just keep doing the same thing. So now what's the most convenient to combine? You can look at these two resistors. Those are in parallel. So we can rewrite the circuit again. Except now we're going to replace the end resistor with the parallel combination. So remember the formula for two parallel resistors is just R1 times R2 over R1 plus R2. So in this case, we've just got 4 times 12 over 4 plus 12, which is just going to be 3 ohms. And then you just rewrite all the other ones. And now we keep going. What are we going to replace this time? Well, these guys are in series. So we can just say 3 plus 3 is 6. There's still a 6 ohm right there. And there's still a 4 ohm and a 3 ohm. Now we're getting smaller. This is 2 in parallel. So 6 times 6 is 36, divided by 6 plus 6 is 12. So that's going to be 3 ohms again. 4 ohm, 3 ohm. And now the final step. These three resistors are all in series, so we can just combine them into one. Four plus 3 is 7, plus 3 is 10. 10 ohm. So that means REQ equals 10 ohms.